Hi guys, welcome as we do this question. Guys, I read the question first. Prove that A is equals to, that is the matrix, having first row 1, 2, 3, second 4, 1, 5, and 6, 0, 2 for the third row. Has inverse, A inverse equals to 1 over 28, and then you have that matrix. And of course, you are given a hint here. Guys, for the hint, you can use it to test if the answer is correct. And so guys, I start off the question. So we have the question right here. Guys, the first thing we are going to do is to find the determinant of the matrix. For us to find the determinant of the matrix, we are going to have 2 by 2 matrix represented by this position. Of course, we multiply by 1. And this position and this position. For the first position, guys, this is what we have. We come and close or hide the row and column of number 1, like that and like that. So guys, whatever remains is what we write. So for the first one, we shall have 1, then 1, 5, 0, 2. Guys, we use that pattern. When we come to 2, we hide the row for 2 and the column for 2. The row and the row and the column. This is the column and this is the row. So we are left with 4, 5 and 6, 2, just as we have here. The same case applies to 3. From there, guys, we now come and multiply the major diagonal, the product of that is the major diagonal, we subtract the minor diagonal from the major diagonal. That is 2 minus 0. Then we multiply by 1, that comes to 2. This is 4 times 2 is 8. 8 minus 30 is 22 times 2. Negative 22 times negative 2 becomes 44. And for this one is 0 minus 6 comes to negative 6 times 3, it comes to that. So finally, guys, we get 28 as our determinant. The next step, guys, we go to the matrix of cofactors. For the matrix of cofactors, guys, we just going to represent as we have done here. Now we shall not have this 1, 2, and 3. We shall have only that. For the position of number 1, we have that. No, for remembering, we have this pattern. For the position of number 2, we have this. Now without 2 and without also 3. And for that, guys, I have already done it is here. And as you can see, for the first row, it is the same numbers we had except the numbers that were supposed to be here, which was 1, negative 2, and 3. So the same case happens to all of them. Guys, we can do for this and then we continue. Coming to the second row, guys, we have a 4 here. So we hide the column of 4 and the row of 4. So we are left with 2, 3, and 0, 2. And that's what I have written here, guys. 2, 3, and 0, 2. Guys, we come to 1. For 1, we hide the column and the row of 1. So we are left with 1, 3, 6, 2. And that's what we have. So guys, we do that for every position. Guys, we call this one matrix of cofactors. After we have done that, guys, now we go ahead and now find the determinant of each of them. And not really the determinant, but guys, we find the product of the major diagonal and the product of minor diagonal, and we subtract major diagonal from the minor diagonal from the major diagonal. For this is 2 minus 0. For this we have 8 minus 30. For this one we have 0 minus 6. We do that, all of them. And when we do that, guys, this is what now we are going to have. This now is going to be the matrix of cofactors. As you can see, the C represents the matrix of cofactors. To find the inverse, guys, we transpose the matrix. Before we find the inverse, first we transpose the matrix. That is to say, we now write the row, convert the row into column. So if we have a row 2, negative 22, and negative 6, that is going to be our first column. The second row now becomes our second column. And the third row, which is 7, 7, negative 7, becomes our third column. That means we have transposed the matrix. And now we come to the inverse. For the inverse, we now come and multiply the transposed cofactor matrix. We multiply by 1 all over determinant. And this is what now, guys, we have. 1 all over determinant multiply by the matrix that is transposed. That is the cofactor matrix transposed. And so, guys, this is our solution. Even as we look, we can see it from here. You can see this is still the same. What we have 1 over 28, 1 over 28, and this is now the same. So, guys, that's how we get to the A inverse for the 3 by 3 matrix. And so, guys, thank you for listening to me. Bye.